So we all know renewable energy is the future, right? But solar power, it's got this wild side. It's incredibly powerful, sure, but it's also super unpredictable. It's like trying to tame a wild animal. Well, today we're going to see how AI is stepping into the ring to do just that.
All right, so what is the big deal? I mean, it's sunshine, right? How can that be a headache for our power grid? Well, it all boils down to one simple but honestly massive challenge.
Okay, just look at this. This is not some smooth, clean bell curve you might imagine. Nope. This is the real deal. This is the actual power pumping out of a huge solar farm moment to moment. It is chaotic. It's jagged. You've got these incredible peaks and then, bam, these sudden deep valleys. This is what a grid operator is staring at every single.
And that brings us to the million-dollar question, right? Think about it. To keep the lights on, you have to match electricity supply and demand perfectly, like second by second. One slip, and you get blackouts. So, how on earth do you power a country with this? The stakes are just incredibly high. You know, there's a technical term for all this chaos. Intermittency. It's a fancy word that just means the power source isn't constant. A single cloud floats by, and your power output just tanks. The sun goes down, and poof, it's gone. For the people who plan our energy grid, who live and breathe this need for perfect balance, this is, well, it's a nightmare. Okay, so that's the problem. But what if? What if you could see the future? What if you could predict those wild swings before they even happen? That's where we pivot from the problem to the solution. Let's dive into how we're teaching AI to be a kind of energy fortune teller. So how does it work? Well, think of an AI forecasting system like a data-devouring machine. I mean, it just gobbles up everything it can get its digital hands on, historical weather data, satellite images, you name it. Then it just crunches and chews on all that info, finds these hidden patterns that we'd never see, and spits out a forecast that's, well, surprisingly accurate. It's literally learning from the past to see the future. And it's getting scarily good at it. And the secret sauce in this case is a technique called random forest regression. It's such a clever idea. See, instead of betting everything on one single genius predictor, the AI builds an entire team of them, a whole forest of individual decision makers. It's kind of like having a brainstorming session with hundreds of experts all chiming in at the same time. And this visual shows you exactly how that works. Each one of those little trees takes the data and makes its own simple guess. Some of them are going to be right, some will be way off. But, and here's the magic, by averaging all those predictions together, the model basically cancels out all the individual mistakes, all the noise. What you're left with is one final, super robust forecast. It's literally the wisdom of the crowd, but in the form of an algorithm. So why do all this? Why go to all this trouble? Because it's about learning cause and effect. The AI isn't just mindlessly crunching numbers, it's learning the secret language of the sun and the sky. It's figuring out, okay, when this type of cloud passes at this angle and the temperature is this high, the power output drops by exactly this much. That is the key. That's how you tame the beast. All right, that's the theory. Sounds great on paper, right? But does it actually work in the real world? Let's find out. We're going to take a look at a case study from a massive solar farm in Malaysia, where they put this exact AI to the test. So, here's what the researchers did. They took their random forest model and just fed it a ton of data. 4 years worth of detailed information from this farm, recorded every 30 minutes. And I mean, they gave it everything. Sunlight intensity, the temperature of the actual solar panels, the ambient air temp, even the wind speed. It's like they were teaching the AI the farm's entire life story. And here we go. This is the moment of truth. The green line you see, that's reality. That's the actual, real-world power generated by the solar farm. And the red line, that's the AI's prediction. Just look at how closely it tracks the real thing. It's not just close, it's practically its shadow. It's an absolutely incredible feat of, well, digital fortune-telling. So what was the final score? The study came up with this number, 87.16% accuracy. And at first glance, that sounds amazing, right? Problem solved. We did it. We can predict the sun. Well, maybe not so fast, because this is where things get really interesting. See, it turns out that how you measure success can be just as important as the success itself. So what does a number like 87.16% really tell us? Yeah, let's dig into that, because this is a super important point. In the world of data science, a single flashy number, especially a percentage, can sometimes hide more than it actually reveals. We've got to be a little more critical. So it turns out there's more than one way to keep score here.
On one hand, you have something called mean absolute error, or MAE. That basically just tells you, on average, how big the AI's mistakes were. Then you've got this other thing called R squared, which is different. It tells you how much of the sun's chaotic behavior the AI actually managed to explain. And this is where we see the problem with a metric like MAE. The study found the average error was about 1,200 kilowatts. Now, is that good or bad? Well, who knows? If you're talking about a few solar panels on a roof, an error that big is a total disaster. But for a solar farm the size of a city, it might just be a rounding error. See the problem? Without scale, without context, the number is basically meaningless. And this is why something like R squared is so much more useful. First, it's always a number between 0 and 1, which is easy to understand. But more importantly, it gives you a proportion. It directly answers the real question. What percentage of the sun's crazy up and down behavior did my model actually capture? And because it's a proportion, it's a universal yardstick. You can use it to compare a model in Malaysia to a completely different one in Arizona, no problem. And hey, don't just take my word for it. The scientific community is really starting to agree on this. This quote from a paper in 2021 lays it out pretty clearly. R squared is just flat out more informative. It tells you a much truer, more complete story of how well a model is actually doing. So let's circle back. Can AI tame the sun? Yeah, it really looks like it can. But here's the bigger takeaway, the real kicker. As AI becomes more and more powerful, woven into everything we do, maybe the most important question we can ask isn't just how smart is it, but how are we measuring its success? Because what we choose to measure is what we're teaching it to value. And in the end, we're not just building a smarter power grid here. We're trying to build a smarter future. And that's something we have to get right.